The announcement sent a jolt through the scientific community because James Webb confirmed that 3 Atlas had altered its course in a way no ordinary object should. The latest data revealed a definite change in its motion, and every updated model now pointed to the same result as the object accelerated toward Mars. Researchers stated that this was no longer a simple comet moving through the solar system, and the event could become the most unusual moment ever documented in modern astronomy. If the trajectory was truly this direct, then what could have driven an interstellar traveler toward a planet? What occurred at the beginning of its journey that caused scientists to monitor it so intensely? The story of 3I Atlas began in the mountains of Chile, where the Survey Telescope system known as Atlas detected a strange object crossing the night sky on July 1st, 2025. The situation grew serious almost immediately because early measurements showed a velocity that did not match any known comet from the outer solar system, and its path resembled something arriving from deep space. Scientists soon confirmed that its orbit was hyperbolic, meaning the object was not bound to the sun. And this single detail proved that the visitor came from no familiar region. The first team to follow it noticed that its motion cut across the sky at an angle opposing the direction of the planets. This unusual behavior made it clear they were observing something that had been traveling for an extremely long time. As observations continued, the object became even stranger because its brightness stayed constant as it crossed different regions of the sky. Comets from distant regions usually change as they warm under sunlight, but 3 Atlas maintained a steady glow, raising new questions about its structure and internal makeup. Researchers estimated its age at more than 8 billion years, placing its origin well before the formation of our solar system. This detail helped them realize they were witnessing a fragment of ancient matter that had survived violent conditions around another star. The idea that such an object had crossed the vast distances between stars filled the team with both awe and caution, since even a small body moving at such speed could have unpredictable effects on any world it passed. Early trajectory models showed that the object was not drifting randomly. The line it traced through space moved with a precision that drew closer scrutiny from scientists. When its incoming angle was mapped, they found it would cross the planetary orbital plane almost exactly, and the probability of that occurring by chance was extremely low. The object moved through the solar system as if following a route shaped by long-term cosmic forces. And this image made the scientific community focus intensely on every new reading. 3 Atlas became only the 3rd interstellar object ever recorded. This fact alone made the discovery historic, since only 2 others had been observed before, and neither had entered the system with such clarity. Each new night delivered more data confirming the early conclusions, and excitement grew as the object showed no sign of slowing. The event quickly became a global topic because the idea of observing a visitor older than the planets raised deep questions about what kinds of systems could create such bodies. It also led researchers to wonder how many other travelers might pass through unnoticed. If one object this ancient could enter the system so clearly, how many more might be moving unseen between stars? What element of its strange trajectory first revealed that something was truly wrong with the orbit of 3 Atlas? The unusual orbit of 3 Atlas became evident once scientists charted its early path, because the object moved in a direction almost no natural body within the solar system follows. The main shift was clear, and each measurement pushed researchers closer to the conclusion that something was behaving abnormally. 3 Atlas traveled on a retrograde path, meaning it moved opposite the planets. And this rare pattern caused the team to examine the data with extreme care. Most visitors from the outer regions follow long curves shaped by gravity. Yet 3 Atlas cut through space as if it ignored the usual pull, and its slight angle of just 5 degrees from the orbital plane added to the mystery. When the first models connected these details, the object looked less like a wandering comet and more like a traveler entering the system along a path set long before it reached the sun. The next detail that heightened the tension was its extreme speed. The incoming velocity was so high that sunlight barely influenced its motion. Typical comets slow slightly as they fall inward, but 3 Atlas continued almost unchanged, suggesting that the force guiding it came from outside the familiar environment. Engineers repeatedly checked the data to rule out tracking errors. Each verification returned the same result. The object moved with a precision that seemed unlikely for something drifting for billions of years, leading scientists to ask what kind of event could launch a body at such speed while keeping its direction nearly perfect. Early predictions grew more troubling when projected path showed 3 Atlas passing close to Mars. As the orbit aligned with a narrow region few natural bodies ever cross. When researchers advanced the timeline, the path approached Mars with increasing certainty, and the likelihood of coincidence dropped even further. The finding did not imply intelligent control, but it did reveal an order shaped by distant forces that no one fully understood. As more observatories joined in, the models tightened, and the object's motion became the subject of nightly reports shared worldwide. What made the situation even more unsettling was that the orbit remained stable despite varying gravitational influences from the planets, which normally cause gradual drift. 3 Atlas passed through these regions without losing its course, challenging assumptions about how interstellar objects behave after entering a new system. By the time James Webb confirmed the directional shift, most experts agreed the orbit matched nothing seen before, and the approach toward Mars appeared deliberate only in the sense that natural forces alone could not explain the alignment. If the orbit was already this exact, what happened when 3 Atlas moved close enough for Mars to observe it directly? The close passage of 3I Atlas near Mars became one of the most important moments in modern astronomy because it allowed scientists to study an interstellar object at an unprecedented distance. The event occurred on October 3, 2025, when the object passed just 0.19 astronomical units from the planet, placing it within range of several high-resolution instruments orbiting Mars. Both the Mars Reconnaissance Orbiter and the MAVEN mission were ideally positioned, capturing details unreachable by Earth-based telescopes. This moment changed everything, as the scientific community quickly recognized the value of the encounter. The MRO team used its powerful camera system, revealing a clear coma around 3 Atlas and a faint dust trail extending behind it. These features differed from ordinary comets, yet the camera recorded them with remarkable clarity. The smooth brightness around the object allowed researchers to define the size of the gas cloud forming around its core. MAVEN observed the approach from another perspective, measuring how charged particles moved around the object. The data showed subtle shifts in the plasma environment near Mars, suggesting the material escaping from 3 Atlas interacted with the planet's thin upper atmosphere. These observations were especially valuable because Earth could not achieve the same level of detail. Distance, atmospheric interference, and limited viewing windows constrained Earth-based instruments, while the Mars orbiters maintained constant focus. The combined efforts of both missions provided a rare data set, enabling precise estimates of how the object shed material as it moved through the inner system. This allowed scientists to compare 3 Atlas with known comets, and the differences forced them to question long-held assumptions about interstellar bodies. Another surprise came from the timing, since Mars was never expected to serve as an observation platform for an interstellar visitor. The orbiters were designed for planetary science, yet they suddenly assumed an unplanned role. Their instruments recorded every shift in brightness and every change in outline, and the combined data showed that 3I Atlas behaved unlike anything normally seen in the region. The event demonstrated that active spacecraft around other planets could open new paths in astronomy by providing entirely new viewing angles. Researchers were left with a new question, as the strange features observed near Mars suggested deeper mysteries within the object's core. If the images already looked unusual, what would the chemistry reveal under closer examination? What hidden clues within 3 Atlas forced scientists to rethink everything they knew about comets? The chemical signature of 3 Atlas became the next major shock, as spectroscopic data revealed patterns unlike those of any comet normally observed in the solar system. The focus shifted, and each measurement challenged previous expectations. Analysis of the surrounding gas showed unusually high levels of carbon dioxide compared to water vapor, a ratio inconsistent with comets formed near our Sun. Most comets release large amounts of water when heated. Yet 3 Atlas emitted far more carbon dioxide, hinting at an origin far colder than any familiar region. Dust grains offered another clue, as their reflective properties did not match patterns shaped by the solar wind. Instruments recorded particles scattering light smoothly, suggesting a different internal structure. These particles also moved through the coma more steadily than expected, implying the material formed under different chemical rules or pressure conditions. The idea that 3 Atlas developed in a distant system with its own timeline reshaped interpretation of the data, and each new reading strengthened the view that it preserved a record of another star's ancient environment. Another detail emerged from the gas near the nucleus, where molecular ratios failed to match any known comet group. The pattern suggested formation beyond the outer limits of a protostellar disk, in a region where carbon-based ices appeared before water crystals. This placed its birth in a zone colder than the Kuiper Belt and far beyond the gas giants of other systems. Studying such material within the inner solar system felt almost unreal, giving astronomers a chance to examine chemistry shaped by a history older than the planets. The unusual chemistry raised questions about how interstellar bodies survive long journeys, as the molecules within 3 Atlas appeared stable despite radiation exposure. Some scientists proposed a denser interior that shielded original material. Others suggested a unique layered structure preserving ancient molecules while newer material escaped during heating. The strong carbon dioxide release supported the idea that the surface held clues to its birthplace. The findings energized research groups worldwide, as every detail pointed to the same conclusion: 3 Atlas did not behave like anything known in the solar system, forcing scientists to rethink what comets could be when formed around other stars. If the chemistry was this strange, what would happen when the object entered a path aimed directly at Mars? And if the chemical clues were already this unusual, what occurred when scientists realized the orbit itself was changing in ways they could not explain? The most disturbing moment came when scientists realized the orbit of 3 Atlas had begun to shift, no longer matching predictions based on classical celestial mechanics. This turning point pushed the scientific community toward the same uneasy conclusion. When 3 Atlas passed Mars, several observatories detected a subtle change in its motion, with the angle of its path altering beyond what Mars gravity could explain. The shift was small but significant, creating a trajectory that pointed more directly toward Mars than any earlier model suggested. James Webb confirmed the change with high precision, using infrared instruments to track the object across multiple observation windows. The new vector showed that 3 Atlas had not simply continued along its original hyperbolic path, making it appear as though something had nudged it. Scientists searched for evidence of a sudden outburst of material, but found none. They examined possible magnetic or solar wind effects, yet nothing matched the force required to explain the change. With no clear cause, confusion grew, and research teams proposed 3 main theories. The first suggested the object passed through a stream of energetic particles from an unknown source, acting as a force, but data showed no radiation spike. The second proposed an internal structure that reacted uniquely to sunlight, releasing gas unevenly and shifting the orbit. This aligned with earlier chemical anomalies. The third theory sparked the most debate, suggesting an internal mechanism not yet understood. It did not imply intelligence, but it raised questions about natural processes in a body older than the solar system. All 3 theories led to the same conclusion. The new orbit now targeted Mars with greater accuracy. The shift appeared too deliberate to ignore, as calculations showed the path narrowing toward a specific region of Mars' orbit. Experts warned that if the change continued, 3 Atlas could intersect Mars within weeks, transforming scientific fascination into global concern. The event became the focus of nightly updates, with researchers revising trajectory models every few hours to track even the smallest changes.